floor is yours.
Okay, let me know if you can see the slides.
Yeah.
Okay. Okay. Hi everyone, I'm Federico Princiotto from Linux Foundation. I will show to you how we tested and implemented the interoperability between the 5GMETA and 5GMETA platform. Just to give a little bit of context to the demo, I will also briefly explain what the 5GMETA platform does and what the 5GMETA platform does. So starting with 5GMETA. 5GMETA in a nutshell is a data-centric IoT messaging platform specified for connected automatic vehicles. The idea is to create a monetization ecosystem that can allow different stakeholders to create different applications based on autonomous vehicle, connected vehicle, and 5G connectivity. So what the platform does practically is to act as a bridge between any data producer and any data consumer for CAM data. A data producer can be either a smart vehicle, a vehicle mounting an onboard unit, or a completely autonomous vehicle, but can also be smart infrastructure, for example, cameras mounted on the road or a roadside unit. For data consumer, instead, can be any third party that wants to consume real-time data from vehicles to perform some kind of service. The idea is to perform decoupling between producer and consumers. So you will have data producers from around the world publishing data into 5GMETA platform, and then any data consumer in any position can ask for some specific data and retrieve real-time data. The idea is that 5GMETA platform does not perform storage. You will only receive real-time data as it comes. Of course, 5GMETA platform provides a lot of features. I will not list all of them during the presentation because it will take a lot of time, but the main points is that provides some 5G features. We have MAC servers connected directly to 5G to the vehicles to provide some service with low latency. And any consumer can ask for specific filters on the data they want to consume. So can ask for only this type of data in this position, filtering by, for example, quad key. Of course, there are a lot of features, but I will keep it short. What about 5G IANA? 5G IANA is an experimentation platform to enable in an easier way the deployment of automotive-related application in 5G environments. The idea is it can be used as a framework to ease the development of new application for automotive and 5G environments for SMEs. 5G IANA revolves around the concept of network application. A network application is defined in 5G IANA as any virtual application that exploits 5G infrastructure and 5G service to provide something. A network application is composed of one or more functionalities. It can be either application function or return function. An application function is a software component that provides service logic, while a network function basically provides control on the network or communication. So what 5G IANA offers to a user offers a catalog of all the application function, network function, and network application that were developed during the project from any partner in the project. Offers two 5G test sites, one in Ulm provided by Nokia and the other in Ljubljana provided by Telekom Slovenia, and provides a graphical interface to ease the deployment of network application. From this graphical interface, any user can deploy without needing to code any network application, simply selecting which network function, application function he wants to use, connect them to some links specifying which protocol is used, and deploying, selecting also which nodes he wants to deploy these components in a cluster. Of course, 5G IANA provides a lot of features. There is a machine learning distributed framework, you have the possibility to allocate also network resources in the same way used to allocate computing resources in an orchestrator, but this is the main functionality that are needed to understand the demo. So for the interoperability between 5GMETA and 5G IANA, for the ICT41 platforms, we have to decide how to showcase this interoperability. Basically, we had two platforms. One that is a scalable CCAM messaging platform. The other one is an orchestration platform that can deploy automotive software, both in onboard unit and in edge servers in an easier way, and provides also the possibility to deploy modular software components. So what we decided to do is to create two software components, two network functions, to publish them in the 5G IANA catalog, and these two network functions act as adaptive layer to allow any network function, network application in 5G IANA to communicate using 5GMETA as a channel. The idea is something like this. You have a 5G IANA platform in which two network applications are running. One is a sample data producer application running in an OBU, an onboard unit. The other one is a consumer running on edge server. You can add to these two applications those two software components, simply graphically connecting them. The adapter component in the publisher allows to publish in 5GMETA. The other one in the consumer allows to consume from 5GMETA without needing to code to interface directly with the 5GMETA platform. So these two components are, one is this 5GMETA producer adapter, that the only configuration needed is to add as an environmental variable the credential of 5GMETA. And then this component hosts a REST API server that receives any messages and will handle the publishing in 5GMETA, the registration in 5GMETA, the sending of Keep Alive to 5GMETA platform, all the 5GMETA communication protocol performance acts to be performed will be performed by this component that will convert any messages it receives to messages in 5GMETA. The other adapter is this consumer adapter. It acts in a similar way. You need to configure it, basically setting which data you want to consume, so the data type, the quad key, what type of license you want to consume, all the filters that the 5GMETA platform allows to a third party to consume data. And then you also select in which broker you want this data to be sent. What this components does is receives this configuration environmental variable, subscribes to 5GMETA, receives the messages you need to receive and forward them to any IoT broker that the party want to use. In this way, any consuming application can be converted to a 5GMETA consuming application, add this software component to the graph. So what we did in Aveiro basically is showcase an example application using those two components. So we had the graphical interface of 5G IANA with both a 5GMETA publisher and a 5GMETA consumer network application deployed. Basically, the graph is very simple. We have these two software components. One is a software component that reads the GPS of a virtual OBU and sends messages to the 5GMETA adapter, and then this 5GMETA adapter performs the registration and sending messages directly to 5GMETA. In the same way, we have the in the same way, we have the 5GMETA consumer, three components, very simple. One is the consumer that is set in such a way to receive this type of messages, forwards the messages to a broker, and then a very simple consumer deployed in links reads these messages and show them in a web interface. In this case, the consumer is a web interface visualizer that can show any CITS message it receives. In this case, it was CAM messages. So what the visualizer show is the position of the vehicle in real time, but any application can be linked to this architecture. So just to sum up, the interoperability was tested, creating two software components, two network functions as an adaptive layer between the two platforms. These two software components are already available in 5G IANA for any user of 5G IANA platform to use. And basically, any application that follows this software graph architecture, in which you have a publisher and then the adaptive layer, and then a consumer connected to the adaptive layer developed, can convert any software application in a 5GMETA publisher or consumer application. Thank you for your attention.
Thank you very much, Federico, for this insightful description of the interoperability between these two platforms and how these two projects interact with each other. I would like to remind the audience once again that we will collect questions and we will answer them after the third speech. So in case you already have some, please add them to the chat or the Q&A section, and I will then ask them to the speakers. So we can go on now with our second speaker, who is Christophe Couturier from Yogoko. So please, Christophe, hello. You can go on and start with your presentation.
Hello, good afternoon, morning, I don't know. I will share my screen, and just to tell you that I will stop my camera because I have a limited connectivity today. So I apologize for that, but just please confirm if you see my screen.
Yes.
Okay. So I work for Yogoko. Yogoko is a French SME. And our goal is to provide connectivity solution for mobility application developers. And we are a member of the 5GAS project. So today I will give you a quick introduction to the 5GAS project, tell a few words about the promises of 5G about vehicular communications. And I mean promises because you'll see that we probably don't match yet all the promises. Then I will show you how the network application developed by Yogoko in the scope of 5GAS can contribute to improve the 5G adoption. And then explain how we want to contribute, to collaborate between 5GAS and 5G IANA around the net developed by Yogoko. So let's start with the 5GAS project. So I don't present 5G IANA because Federico has already done, and probably you will have those insights later on. So 5GAS is finishing actually because, sorry, there's a mistake in the slide. It's not March 2023, but 2024. So we will end in a few months. The purpose of 5GAS is to develop a platform that can host application and that can serve test of the network application, and in order to certificate them, to certificate that they are running correctly, that they are compliant to the 5G standards, etc. This is in short. We are 30 partners, and we develop. So some partners are providing the infrastructure and virtualization and scheduling schemes, solutions. We can virtualize either a virtual machine or containers. And in addition to this solution provider, we have also partners that provide network applications. So we call them net apps. So in the scope of the project, we develop 11 net apps that are spread mainly across two verticals. So the first one is automotive, and the second one is public protection and disaster relief. And some of the net apps can be cross-vertical. For instance, when we speak about privacy issues detection and things like that. So this slide is to explain what is the need of communication and how we handle communication in what I call CITS, so Cooperative Intelligent Transportation System. Most of you probably know that we have basically two ways of communicating. We use two ways of communication in the scope of ITS. The first is what we call direct communication. So this is where communication happens directly between the devices. The devices could be cars, infrastructure equipment, other users, other road users. And we have technology dedicated to establish this communication without the need of extra infrastructure. So namely, these standards can ITS G5 in Europe, WAVE in the United States, and in the scope of the 3GPP, we have currently CV2X, and with the 5G, we have the promise of the future NR V2X. But we could use also other technologies, for example, like Bluetooth Low Energy, to do this kind of communication. And the other scheme of communication is the well-known long-range communication, so typically based on IP, so relying on 3G, 4G, or 5G in what we call UU mode. Depending on the application, we can use either of these two standards, of these two schemes, and either of these standards. So this raises some questions. The first question I want to raise, and I will answer it right now, is the problem of wording. The wording, when we speak about V2X, vehicle to everything, depending on the people who speak, V2X can encompass both modes of communication, so direct communication and long range. So in this case, it means any kind of way to communicate between cars and road users. Or for some of the speakers, V2X is limited to what we call direct communication. And in this case, we oppose V2X to V2L. So in the wording of 5G AA, for instance, V2X encompasses all of that. But I think it's important to clarify that. Then the second question is, wow, there's a lot of standards. How can we build applications that discuss together with all these standards? For instance, how can I implement vehicle to pedestrian? Typically, pedestrians are currently not equipped with this kind of technologies, while cars are equipped with that. So how can I bridge this communication together, this technology together? And the last, so I will answer that. And the last question I want to ask, maybe not to answer, is what is really available today on the market to deploy today yet? So we'll try to see that in the presentation. So this slide is quite variables, but it's just to underline that we have a lot of standards. So for direct communication, I mentioned ITS G5 and WAVE, and we've currently with the 4G, we have introduced CV2X. CV2X is available today for cars, and for roadside units, of course, but it is not implemented in eNodeBs. For instance, you can't buy a base station that speaks CV2X. You have to add something extra. And we have the promise of the new generation V2X with 5G, but for now, it is not yet available also. But there is a lot of promise on that. And of course, we have what is available is 4G and 5G UU communication. And we have also a lot of other communication technologies, for instance, LoRa for IoT, but also protocols for smart grids and for mobility data exchanges. I mentioned GTFS, which is about scheduling for public transportation, etc. So once again, we have a lot of standards and technologies to make cooperate between each other. So the first NetApp provided by Yogoko in the scope of 5GAS is called VRSU, so virtual RSU. So a physical RSU is something that you deploy on the side of the roadside unit, and that can broadcast messages using one of these direct communication technology. So what is a VRSU? So The intention of the VRSU is to enhance the GNOD by adding some software and some hardware. So basically, we add a small piece of hardware here that makes the GNOD be able to send and receive message on using the either the CV2X or the ITS-G5 or the NR-V2X technology. And we add a piece of software in the GNOD controller, and more precisely in the make. So this is a virtual piece of software that relies on the make. And with that, we can communicate with the device on the field. And we can also provide V2X connectivity to any kind of infrastructure equipment. For example, a traffic light or a community camera or a variable message sign, etc. And doing so, we make the promise of the GPP of having a V2X enabled network. We make that a reality. The other etap is what we call central ITS station. We call it like that because it is the name that is used in the standard, in the ISO and ETSI standard. And it basically does three things, you will see. It brings V2N connectivity, it handles the scalability of the device, and it enables to connect third-party software. So let's start with the third-party software. This is what you see there. This is basically other service operator that wants to access to the V2X network. For instance, a road operation center, a car manufacturer, a fleet manufacturer, a transportation service provider, or whatever. And to do so, we provide this CITS NetApp that makes them possible to enter the V2X network, and our CITS NetApp will do the logic, will implement the logic in order to put their message into the CITS standard. So this is the first part. The second part is that the CITS NetApp will manage the connection with all the VRSU NetApps, and it will be able to scale using a protocol like MQTT. And doing so, we are able to bridge, for instance, V2X radio head that is working in ITS-G5 with another one which is working in CV2X, sorry, and also with a smartphone that is operating standard UU-Link over 4G or 5G. So thanks to that, we make the necessary bridging between these technologies. So now, how do we intend to collaborate between 5GASP and 5G-IANA? The work will focus on the CITSS NetApp, and we'll first start to bring the development that we made on 5GASP. We will port it to the 5G-IANA. So basically, on the first version of our NetApp on 5GASP, we were running on VMs, on virtual machines. And we first have ported our virtual machine implementation onto containers. So on 5GASP, to run container, you describe them as nchart. So we have onboarded our containers on 5GASP. So the next step is to adapt this end description to the 5G-IANA description standard, which is similar but not identical, in order to have our application onboarded. Okay, that's nice. But doing so, we just ported our function to the 5G-IANA, but we won't take all the benefits of 5G-IANA. What the main benefits that we want to exploit in the 5G-IANA platform is its modularity. 5G-IANA can be seen as something like a puzzle to assemble different basic functions in order to make a bigger network application. And in our CITS NetApp, we have two parts. We have one part that implements the CITS logic, and one part which is basically a MQTT broker. So we will split our NetApp. We will remove this MQTT broker, which is not actually the added value of Yokoko. We will remove it from our NetApp, and we will use the MQTT implementation that is provided by 5G IANA in order to build a new NetApp that will be an assembly between the logic of Yokoko and the classical ActiveMQ implementation of MQTT already available on 5G IANA. And doing so, we will simplify our NetApp, we will simplify our development process, our integration process, etc., etc. So what you want to take away from this presentation, just remember that with the Yokoko's NetApp developed by the scope of 5GASP, we enhance the promises of 5G because we make the 5G network and even a 4G network actually V2X enabled. So with this NetApp, your 5G or 4G network can speak CV2X and tomorrow NRV2X, and why not ITSJ5 if you want, we can do that. With the second NetApp, we can provide interoperability between very heterogeneous set of standards, including different communication technologies, and including also higher level of interoperability, higher protocols that are higher in the stack. And we can do that thanks to what 5GASP and 5G IANA brings. So namely the virtualization and the capability to run in the make, the integration with the 5G core that we have done in the scope of 5GASP, and the easy development and testing approach that are followed by both projects, namely using DevOps solutions. And from the 5G IANA, we benefit from the modular integration. So I really want to underline that 5G is yet available for automotive. So we are waiting for you in order to come to test that on our 5GASP and 5G IANA platform. Thank you very much.
Thank you very much, Christophe, for this presentation on different aspects of 5G application in CITS and also on how interoperability is important for 5G and 5GASP projects. Hopefully this insightful presentation will be of inspiration for our audience. So I would like now to give the floor to Juan, our last speaker, who will present about VITAL-5G and 5G IANA interoperability. I can see your screen, Juan, so the floor is yours. Thank you.
Okay, thank you, Gianmarco. So yes, as you said, today I will have a short presentation covering mainly the results that we had in this Aveiro workshop, in which we did two demos related to the interoperability of our experimentation platform. So we had some network applications from 5G IANA and from 5G Induce running on VITAL-5G experimentation facilities. And so I will focus the presentation in which were the challenges that we needed to face and to overcome in order to be able to bring in network applications developed targeting and other experimentation platforms into the VITAL-5G. I have structured this presentation. First, I will cover some background knowledge about VITAL-5G so that you can understand the different concepts. Then I will explain briefly the two demos that we ran and these two interoperability demos that we had the opportunity to perform at this workshop. And then I will go into what we understand were the lessons learned after these interoperability demos and which were the most challenging parts in order to orientate the discussion towards what could be addressed in terms of operability. So let me just first start with the a description of what VITAL-5G actually is. As you can see in the slides, first of all, we have 3 different testbeds, one in Antwerp, one in Romania, in Daruga and Galati, and one in Athens. Each of them has its own 5G core deployment with some 5G slices available, and each of them it's focused on different, let's say, use cases related to transport and logistics. So we have 2 different ports, one in Antwerp and one in Galati, and then we have the Athens service, which is covering mostly a transport and logistics facility, a warehouse. On top of these test beds, we add the 5G platform, okay, which offers the experimenters and the users of the VITAL-5G some services that allow to experiment on top of our test bed. So basically, as in the case of 5GMETA, as you saw earlier, we have a catalog that enables experimenters and network application developers to onboard their applications. I will explain in the next slide what a network application means in the context of VITAL-5G. And then we also have some services that are exposed in order to be able to run your services on the testbed facilities and get some results back in terms of KPIs and monitoring data. So basically, we allow the experimenters to assess how their services could run in a 5G-enabled environment. Basically, we follow the same approach that you saw earlier in the 5GMETA presentation. Basically, this slide seems to represent what a network application in VITAL-5G really is. So on the one side, we have the usual, let's say, VM images and software images that have the logic of our of the applications that we want to run. But in VITAL-5G, we have something that we call the network application blueprint, which adds the 5G flavor, let's say, of the application. So this network application blueprint allows to describe the 5G-like characteristics that you need in order to run the application, latency, data rates that you need in order to connect to the coverage area, let's say. Then we also enable the capability of adding some metrics that the platform will automatically collect. So, for instance, we can collect automatically latency parameters from the testbed infrastructure. So we have interfaces over the testbed to retrieve this in an automated manner. And we also enable with this blueprint the capability of describing which are the required 5G core services that your network application or the experimental network application would need from the specific 5G deployment in order to work. This is as you can see here, I'm not sure if you can see my mouse, but this is a JSON representation of what actually a network application blueprint is. So basically, JSON representing this graph that you see in the left. Here you have the infrastructure metrics that you want to collect. The endpoints can be attached to MBB ULC slice, so this will automatically attach your service or the network application to a slice following this or enforcing those characteristics into the testbed. We had 2 different demonstrations, as I was saying, that came out as a result of different collaborations from different projects. In the first one with 5GMETA, we have this deep learning object detection network application deployment in our transport and logistics facilities. For that, we used the Athens testbed. So this is, as you can see, the objective was to validate how this network application that was developed in 5GMETA could be deployed and actually consume a video stream that was provided by one AGV that was present at the Athens testbed. And then we have this quality monitoring application that was developed inside the 5G Induce, and we brought in and we deployed in the Antwerp testbed. So this was born as a collaboration between the companies that you see underneath. So at the bottom, Internet Institute, IMEC, Nexus, and Telenet. The target in this case was to first confirm that the metrics that that the VITAL-5G platform was extracting from the testbed infrastructure matched the one that we could extract from the application itself, since it's an application specifically tailored and developed to get some metrics from 5G networks. And also the objective was to see how this application would behave in a port environment. And this is an application that, let's say, a trial that we are still running now. Some details about what we actually did for the this deep learning object detection as demo that, as I said, we developed as an interoperability related demo in 5G IANA. As you can see on the right, we had this AI application that was developed by 5Com. We onboarded this application into the VITAL-5G platform. We attached it to a video server that is retrieving data, a video feed from the AGV. So this video server is serving this AI application a video stream that this deep learning based AI application consumes in order to detect the certain objects. In this case, we wanted the target was to identify people, so maybe a security-oriented, let's say, network application. We deployed this through the VITAL-5G platform. So basically, we onboarded the network application blueprints. We composed a service to attach this AI application with a video service. With a video server, and we deploy this automatically with the VITAL-5G platform. Okay, the only thing that our platform does not really orchestrate is the AGV, which is outside the control, but the rest, in principle, was targeted to be integrated there. And during the demonstration, we actually shown that we were able to retrieve some video stream from the video server provided by Wings and detect some objects. Okay. In the other application that we run, this human application, we basically have deployment in which, as you can see in the left, this is the network application that was developed in 5G Induce. So we brought in some specialized user equipment that to the Antwerp facilities. We attach this to the 5G network provided by Telenet. And we run this QMON, let's say, backend agent on the IMEC testbed facility. So using the OpenStack and the compute capabilities of the Antwerp testbed facilities, so that this user equipment was able to push data towards this QMON backend agent, which was automatically deployed by the platform and attached to a 5G slice. And actually, we were able to get some latency and data rate metrics from the application and from the platform. Currently, we are right now focusing on cross-checking these metrics, as I said. So this is still an ongoing collaboration. A little bit of insights about which is the process that we usually follow in order to bring in a network application into VITAL-5G. Of course, first we have to go through a phase of technical design of the solution. And this is important because every network application that we bring in our platform, of course, if it's going to be doing a meaningful demonstration or a minimum, let's say, a meaningful application, there's a need to interface with some of the devices or the network applications running on the testbed. So every time we start to bring in a network application here, we go through a phase in which we design the network application and see how this network application is going to interact with the testbed facilities. I guess this is pretty much a common thing about projects, but it's important to highlight in order to understand which were the issues that we had at the end. Okay. Of course, once we have established a technical solution, so we understand how the service is going to interact with our network applications and with the testbed, we need to create secure channels for the network application developers to either be able to access the platform and onboard the network applications, or also secure channels towards the testbed to be able to connect to the actual instances of the network applications once they run. Then we need to go through a phase in which the network application developers submit and provide the software images to be onboarded either in Kubernetes, in OpenStack. This is a phase, the phase in which the software is ready, and follows the design established at the design phase, and everything is ready to be onboarded. So it takes some time, but it's also a phase that we need to go through. And then once we have finalized with this onboarding phase and preparation of the software image that need to be onboarded in our platform, we need to somehow extract the information that was described in the design phase and create the service and experiment blueprints to be onboarded in our platform, so that the platform is able to automatically deploy the applications and extract the required metrics and attach the network applications to the proper network slices. As lessons learned, given this workflow that I have just explained, at least from the collaboration we have with 5G Induce and 5G IANA, it is a good thing that we have been using. I guess this is a common thing, among all the experimentation platforms. We have this shared definition of what a network application actually is. So as you saw earlier in the presentation of 5G IANA from Federico, a network application at the end is the logic of the application plus some connectivity requirements that we use to attach to our networks and so on. Of course, each project uses the different data models for representing this, but since at the end the overall concept is shared, it is not a complex task to move from one experimentation platform to the other. The other one, which I guess was a major success, is that we have been using the same tools to, let's say, interact with our infrastructure. So all the projects use either OpenStack and Kubernetes and open source Mano for the orchestration. And this is actually really helpful because when you want to move the application itself, you already have a common format to move the images around. And this was a major success. The other part, which from our point of view is the most challenging, is the part of the technical solution design. Yeah, and this is mainly because, as I said before, if we want to have some meaningful deployments and some meaningful demonstration and some minimal experimentation and some relevant trials, the network applications needs to interact somehow with what is offered by the test facilities. And this is still a complex task, which has been facilitated through establishment of blueprints, in the sense that now, at least the blueprints enable you to let's say, the service developers to explain what the application is actually doing. But there is still some work to do. And this is, I guess, at least from my perspective, the major issue we had with in terms of interoperability, describing which actual services are available from our testbed, so that an external party or someone coming from another experimentation platform can actually understand how to interface with it and consume the services and make something that is really meaningful. Because running applications, of course, it's important, but it's not the final step of the business chain. So that is basically it from my side. Hope I covered most of the the interoperability challenges. If you have some questions, of course, I will be more than happy to answer.
Thank you very much, Juan. Indeed, questions are more than welcome, and thank you for sharing with us this overview on the VITAL 5G project, and as well as interoperability. And it was very interesting to see these lessons learned and best practices that are for sure useful also for the other projects, and will be useful to develop further the application of 5G technology to the automotive sector. And actually, I would like to, first of all, thank all the 3 speakers that we had today. So once again, round of applause for you. And I would like to also open the floor for questions. Once again, you can add them to the chat. But in the meantime, and connected to what Juan just told us, I would like to maybe ask Federico and Christoph, starting with Federico, whether we also have some kind of lessons learned, which are the main challenges that you kind of experienced in the integration work that you have done in these last months, and then we will go on with Christoph. So Federico, if you can answer this question, please.
Okay, can you hear me?
Yes.
Okay, about the main challenges, you need to understand deeply both the platforms before trying to create some link, some interoperability between one platform and the other. So there is a lot of work doing before the developing of the interoperability link, just to be sure that you understand how both platform works deeply. Then once we have this comprehension, it was not too difficult to develop these adaptive layer between the 2 platforms. And so from now on, then using this adaptive layer will be almost without effort to integrate the 2 platforms.
Okay, I see. Thank you, Federico. And I have another question, maybe before going to Christoph. I have also 2 for you. So, Federico, I would like also to understand a bit better which can be the uses of the interoperability that you pointed out, and do you think that the solution that you found that you are working on is scalable?
Okay, for the uses from the 5GMETA size, it opens to more third-party users, because any user of 5G IANA can also be, with almost no effort, also a user of 5GMETA if it wants. From the 5G IANA point of view, now you have an easy integration to a scalable communicational channel. For example, if you have more 5G IANA clustering with different sites, you can use 5GMETA as a communication channel to connect different sites. About the scalability, yes, the solution is scalable. 5GMETA was taught, was developed, designed to be scalable, to be a cloud platform that can handle a lot of consumer, a lot of user. So the solution should be scalable, also integrated with 5G IANA. Thank you.
Great, thank you very much. For sure, some food for thought. And so let's go on with this similar question for Christoph, just to repeat once again. So which are the lessons learned and the main challenges that you experienced in the integration work you have been bringing on lately? And also, do you have any specific recommendation for our audience, or in general, that you would like to give in the minimization to actually to minimize the issues when you integrate 2 different software platforms?
Yes, thank you for the question. So the lessons learned, let's say that at the beginning of the project, we at Yogoko were not expert in virtualization and even 5G, because we came from the ITSG5 community. And so definitely for us, it was a great learn. And what we learned mostly is, I would say, a new way of developing applications. I mean, we were used to agile methods of development. but we were not so used to this DevOps way of doing things and all the virtualization of the infrastructure. And our main pain point, we considered Yogoko as a software company, and our main pain point was about hardware, how to handle hardware. Either on OBU or LSU, it was the same problem. We sell hardware because our customer needs it, but it's not our job. And thanks to the virtualization, we managed to put this problem aside and to focus on our added value. I think it is really a great benefit of this virtualization world, because it helped to focus on our added value and share the value with other partners that are good at what you are not good to. And it is true for our supplier, our subcontractors, but it is also true for our customers who can delegate to us their problem of connectivity. And I think it is really the approach of virtualization that is wanted by the 5G, and we are really in that, and it is yet a reality. So once again, the main lesson is 5G for automotive is a reality. You can deploy CV2X services without taking care of the infrastructure if you need to. But obviously, if you want to, you can go more deep in and to add value in a NETA or in just one component of a NETA. So this being said, there are challenges that are remaining. The first I would see is that we do great things in those projects, but as an industrial who want to supply the services at scale, I am still missing a real telco provider that was that. I mean, today, these services are hosted in our project, at least in 5 years, are most operated by universities, which is great. But we are still on prototypes, and we are not in nationwide accessible networks. This is the situation yet. It is moving very quickly. There are partners like T-Mobile, like Orange in France, like Amazon, who are taking on this topic, and will take the output of our projects, I am sure, to provide that on the mass market. But we are still missing this commercial offer for the moment. And there could be also some improvement because we are just scratching the surface of what we can do with 5G. For instance, in 5GAS, we are experimenting the interface with what we call the NEF, Network Exposure Function. And through that, you can interact with the 5G core, for instance, to instantiate slice on the fly, or to get the position of mobile. And there's a lot of things that you can do that are not fully implemented yet on the networks, and that would open very interesting doors in the future.
Thank you very much, Christophe, for your answer. Actually, one part that you mentioned is the commercial proposition that this research or development and innovation projects have, and indeed this is one part that 5GMETA project also focuses on. And indeed, well, actually, I'm sharing with you in the chat one survey that we launched a few weeks ago, and that will be closed in the next days. So I urge everyone to take a look at this. This is indeed a survey that aims to understand the needs, the aims that different stakeholders might have in these kind of projects, like data providers, data consumers, platform operators. What is behind all of this work? So by taking this survey, we will understand better what the answers to these questions are. And of course, this will provide a source of further development, not only for 5GMETA platform, but as we can see for all the other projects, platforms that can and have to be interoperable to provide the best service. So I would like to ask one last question before probably closing this webinar, and this is for Juan, and is about the platform that you described and whether this is open to third parties applications.
Yes, thanks for the question. So basically, the same way we opened our platform to this collaboration with these two other projects, we are open and without any kind of payment or subscription to our platform, we can accommodate third-party applications. So we are requested to do that. We should follow the same kind of approach in which we kind of discuss the applications that any other third party may bring in. We have different test beds with different facilities. We have some really interesting infrastructure. We have some 5G commercial deployments that could be used to get some insights about how 5G could be used in a real environment let's say to provision our services. So if anyone is interested, the process of joining is pretty simple. It's discovered in our webpage.
Thank you very much, Juan, for your answer. I will just leave 10 seconds to see if any other question comes up before closing this webinar. Okay, I didn't count, but I think 10 seconds have passed. So I would like to thank you all for your attention. Thank you for attending this webinar. Thanks once again to our speaker and to our project coordinator, 5GMETA project coordinator, Gorka. And as I was mentioning in the beginning, we will share the recording of this webinar for dissemination purposes and of course for any reference that you might want to have. So thank you once again and have a very nice day.
Thank you. Bye.